Good day to all of you. I know I'm saying good day because even though it's good morning in America, where rest of the world people are joining all over the world. We have participants right now from about 35 different countries. So we welcome you all on behalf of Coco Town and Scott Johnson. You have all seen Scott Johnson's profile, so I'm not going to repeat it. You can read it on our blog or on our Facebook post. He has so much accomplishments and he has so much knowledge on everything Coco. But what sets him apart is he is willing to give back to the society. So he has graciously agreed to share his knowledge with all of us today. So we are fortunate to have Scott. So without much further ado, I present it to Scott. Please take up.
Thanks, Ando. Welcome, everybody. I'm going to try to share my screen and give me just a second. So you should be able to see my screen. And what we're going to jump into here is just a little bit of a quick introduction. And so I'm going to ask that everybody mute yourselves. We're expecting a couple hundred people from a couple dozen countries. And so to make sure that everybody's able to hear, I'll ask that you put yourselves on mute. And really, to Endo's point, the purpose of this is to provide a basic understanding of what's happening in fermentation, what you can do to control it, what you can do to measure it. And really, my ultimate goal here is to empower farmers and collect them to technical expertise, ultimately to increase their standard of living. And so I want to make sure I give a special shout out to Coco Town for hosting this. And my background is I've spent about 30 years in chocolate between Cargill and Mars, working at the highest level. I've managed their research and development programs. My expertise is in processing and formulation and raw materials. I've been to all the sugar plants in South America, for example, and every dairy plant in New Zealand. And of course, I know a little bit about cacao. I've worked on every continent except for Antarctica. There's not a lot of cocoa that grows in Antarctica. I've also been on the Cocoa of Excellence panel a number of times. I've built some of the largest fermenteries in the world, and I've built chocolate facilities on every continent except for Antarctica. So I've got a solid background in chocolate. And really why I'm doing this is because I've spent so much time with cocoa farmers all around the world. Being a cocoa farmer is really difficult. It's hard work. My experience has been that oftentimes farmers may not really know what they're doing or if they're doing is the right thing. Oftentimes what they're doing is what was passed down from their father or from their grandfather. It becomes a generational thing, but may not really understand why they're doing what they're doing. And so I'd like to help increase the knowledge base of farmers with the thought process that by doing so, we can help improve yield, we can help improve quality, we can help improve or increase the number and types of products that they're offering, all with the ultimate goal of being able to generate higher incomes, right? So if we're able to double the income of a farmer, doubling the income for anybody is life-changing, and for a farmer that can be just incredibly powerful. And so to that end, what I'm willing to do is donate my knowledge and my time to pursue that. And certainly one of the avenues we're taking is in this forum with Coco Town. So by the end of today, my hope is that this is an introduction conversation, right? So and the reason I'm doing this is because this lays the groundwork for future conversations. And so by providing an introductory conversation around fermentation, I hope that we can get some quick wins and some quick hits with farmers around the world being able to implement some knowledge quickly. But should there desire to be a second, more in-depth conversation, this first conversation makes sure that everybody has the foundational so that we understand the second conversation. And I should also say that this is all going to be recorded. And so there's going to be a fair bit of technical content here. And I tend to talk relatively fast, and recognizing that we've got 36 or 38 countries around the world, we want to make sure that we record this so you can come back and watch it 2 or 3 or 4 or 10 times and make sure that you're spending the time with the material that you need to get the most out of it. I do also want to say that if you're a company who's looking for consulting, that's not really what today is about. Today is really about donating time and knowledge to cocoa farmers. However, we may have pulled in some companies who are looking for consulting, and I've done that all over the world. So I would ask that you, if that's your interest, that you hold that for today. I don't really want to spend time on that today. If that's something you want to follow up with me later on, though, we can certainly consider that. The only thing that I'm going to stay away from is anything that's a trade secret. And so, as you've got questions, put them into the chat. And then Cocoa Town will sort of moderate and curate that. We may not have enough time to get to everybody's questions. If that's the case, I'll answer them in an email outside of the seminar. But if we do run across some topics where it's starting to press into things that are proprietary to other companies or trade secrets to other companies, what I'll do is I'll just say, hey, that's a trade secret information. I can't ethically answer that, and we'll just move on to the next question. I do just want to take a second to acknowledge that since this is essentially a group of random people, right? I'm not sure what your background or depth of knowledge is, and so it can be really difficult to give a technical talk when you don't really know the background of everybody on there. And so some of the information may be very basic to you, and some of it may be overwhelmingly technical. I've tried to find that middle ground that would appeal to both types of people. But if I'm moving too fast through some things or some things aren't clear, please make sure to put your hand up and ask the question in chat, and we can come back to that. And then finally, before I get into the content, I do want to sort of also just recognize that cocoa is all about flavor, right? That's why people eat chocolate. It's because it tastes delicious. And flavor is roughly half about what you do with your cocoa after you pick it from the tree, but it's also roughly half of what the genetics are of the cocoa that's being grown. So I'm not planning on spending any time on the genetic component today. This is all going to be around the post-harvest components, what happens during fermentation. And we'll talk a little bit about drying, but really this is a fermentation conversation. So with that as a start, we'll talk about chemistry, we'll talk about temperature, on pH and alcohol. We won't spend a lot of time on this slide, but why don't we start with talking about what is fermentation? So very simply, fermentation is when the yeasts or bacteria that are all around us, they're in your room right now, they're in your farm. When you open up your cocoa pod and your seeds are covered in sugar, fermentation is the yeasts that are eating the sugar. And when your yeast eat that sugar, lots of really interesting things happen. Those yeasts and those bacteria start to produce other things. They're producing acids, they're producing alcohols, they're producing gases, and they're producing heat. And all of that stuff is really, really important for that cocoa bean to turn into chocolate at some point. But because it's producing all this other stuff, the acids and the alcohols and the heat, we can use those things to measure if your fermentation is going the way you expect it to or not. So we're going to walk through this in a little bit more detail, in a lot more detail. But without fermentation, your cocoa bean will never ever taste like chocolate. So when you're selling your cocoa beans, that process of converting it into chocolate is about half done. You're going to control what you control, and what you can control is the fermentation and the drying. But even at that step, if you were to taste that bean, it doesn't taste anything like chocolate. It's not until it goes to the chocolate processor and they're roasting it and they're processing it further that it then turns into chocolate. If you skip this fermentation step, it doesn't matter what they do, it will never ever taste like chocolate. And so this is a really critical first step in making sure that the quality parameters for your cocoa bean are there so that your chocolate processor is going to be able to do what they need to do with it. And so I suspect most of you recognize what this is. This is just a cocoa pod that's cut in half. And really what I want to do is highlight the fact that this pulp is really the critical factor in your fermentation. When you cut open your beans, of course, they look purple, and sometimes you'll see white beans as well, but for the most part, they're purple. And what this purpleness is indicating is, you may have heard that chocolate is good for you. It's good for your heart. When people say that, what they're referring to are the chemicals that are causing this purpleness in your bean. They're called flavanols, and they're naturally occurring. They don't taste very good, but they can be very, very healthy for you. We'll talk about what's happening to these in fermentation so that as you're designing your fermentation protocol, you'll be able to direct that to what your customer wants. If your customer wants something that's heart healthier or has the potential to be heart healthier, well, understand what's happening in your fermentation so you can modify your fermentation protocols to maximize that. The downside to maximizing that is that it of course doesn't taste very good. And so usually it's a combination of finding the balance of how do I develop cocoa flavor while maintaining the flavanols in a way that people still want to eat it. And we'll talk about what that balance looks like. But first off, because we've got folks from all over the world, I thought it would be helpful just to ground ourselves on different ways of fermenting. And so the most common way of fermenting in the world is a heap fermentation. A heap fermentation is essentially just creating a heap of cocoa beans on the ground or on leaves. Very, very commonly used in Africa because it doesn't take any infrastructure, right? All you need is the beans in the ground in which the tree was grown, and you create a pile of those beans at the base of your trees. Because it's so inexpensive, that's why it's so commonly used all around the world. And if you don't have access to the things that we'll talk about here shortly, this becomes an easy way to get into fermenting cocoa beans. But it comes with a lot of downsides. The downsides to this is that it's very inconsistent. One of the reasons it's inconsistent is your heap size is going to be different every single time. And so we're going to talk a lot about consistency and repeatability. Really what your customers want is to expect the same thing from you every time, right? They don't want to be surprised every couple of months or every couple of years by something that's different. And so if you can control the amount of beans in your fermentation every time you've got 200 or 300 or 400 kilograms, then you're starting to bring more consistency to your fermentation, because this pile is going to behave differently if it's 50 kilograms versus if it's 200 kilograms. And when I talk about low thermal stability, which is one of the cons here, if you've got a small pile, a small heap on the ground, and your temperature drops by maybe 10 or 15 degrees Celsius overnight, as your fermentation is generating heat, but your environment is cooling down, that pile is now going to cool down because it doesn't have enough mass. There's not enough beans there for it to retain the heat that it's creating. If it can't retain that heat, your fermentation is going to slow down. So one of the negatives with a heap fermentation is that those heaps typically just aren't big enough to be able to control their own temperatures, especially at night. Or if it rains. Rain is another really good way to cool down your fermentation heap, which is not something that's desirable. Another real problem with heap fermentation amongst most of Africa is that it makes it very vulnerable to theft. And so if you've got thousands of these small piles spread out through your country, it's really, really easy for somebody to come by and pick some of that up and carry it away. And if they're taking away your raw material, of course, it's just stealing money out of your pocket. And so it's much easier to reduce theft with some of the other fermentation methods we'll talk about here shortly. And the final thing that I'm going to say is that as a con of this is that you typically get poor drainage. And we'll talk about what it is that we're trying to drain away as we go through the specifics of the fermentation. But generally speaking, you can see this is sitting on the ground. And if your fermentation pile is generating fluids, it's generating acids and it's generating alcohols, those acids and alcohols now don't really have anywhere to go because it's just sitting on the ground. Boxes are another very common type of fermentation. This will be my preferred method almost everywhere in the world. They typically can be made out of wood or plastic, depending on what raw materials are available. And the holes here they're doing two things. Well, let me start by saying that this is a very, very consistent way to ferment because it's a fixed size. And if you fill this box up, you'll get the exact same amount of beans in there every single time. And so your fermentation heap will now thermally behave the same way every single time. These holes in the box, sometimes you'll see holes, sometimes you won't. I'm a big fan of holes. What this is doing, and again, we'll talk about this in more depth in a few minutes here, but as your fermentation is creating liquids, these holes provide an escape for those liquids. We'll talk about why that's important. The other thing that these holes are doing is later in your fermentation is it's allowing oxygen and air to get into your fermentation mass. And we'll talk about what that's doing as well. But you can see that this is a much more standardized and a much more versatile way to ferment than it is than following the heat fermentation. What I encourage most people to do who are considering box fermentation is to make one side of your box removable, because we're going to want to move this mass around. It's called turning. We're going to mix those beans up. And if you can lift one wall of your box out, it becomes really easy to rake your beans out as opposed to trying to shovel it over the top of your box into another box. So it's essentially a labor-saving device. Now,
Nick, okay, a couple of questions. They want to know what is the optimum size of the box and what happens to the unfermented beans.
Yeah, those are great questions. And so I don't know that there is an optimal size of the box. And generally speaking, I don't like to go less than 300 kilograms. And so 300 to 600 kilograms per box of wet beans is about the range that I like to work in. Anything less than that, I find that I've got real challenges with consistency, usually due to that thermal consistency. If you go less than 300 grams and you've got a cold night or a cold night in combination with rain, your temperature in your box can drop quite a bit. And we'll talk about how do you measure that. Here's a example of a piece of equipment called the data logger, which will automatically measure your temperatures as frequently as you ask it to. So it can do it every second, it can do it every minute, it can do it every hour, but it's a good way to measure what's going on in your fermentation. We'll talk about how to use that. So again, I don't know that there's an optimal one, but anything less than 300 becomes vulnerable to your ambient temperatures decreasing the temperature of your fermentation. Anything larger than 600 kilograms, it can be very, you're starting to run into long fermentation times because there's so much there, and you may run into molding, and we'll talk about molding in a bit. So I hope that answers the question. I think the second question, Andal, was what happens to unfermented beans? In the Ivory Coast, there's a saying that translates roughly to there is no graveyard for cocoa, meaning that everything is going to be used somewhere. And so there is some, if you've got unfermented beans, some of that does make it into the supply chain for cocoa. If you've got customers who aren't very sophisticated at assessing their raw materials, sometimes people will blend that in at maybe 5 or 10% and hope your customer doesn't catch it. Lots of bad things happen when we do that, and we'll actually talk about exactly what's happening when you do that in a little bit. The other major market for unfermented beans is in the cosmetic cocoa butter industry. And so a cocoa bean is roughly 1/3 cocoa butter if it's unfermented. It's 33 to 40% cocoa butter. If it's unfermented, again, it will never ever taste like chocolate. But if you're using cocoa butter, your customer is using cocoa butter in the cosmetic industry, right? They're lotions or things you put on your face. It doesn't need to taste like chocolate. And so there is a fair amount of unfermented cocoa beans that goes straight for cocoa butter extraction. That's never meant for consumption. It's only going to be used in the hygiene industry. So I hope that answers the question. If not, just jump back in and we'll come back to it. The third method of fermentation I just want to touch on is basket fermentation. This is more commonly used in very rural areas of Asia, and it's a woven basket. The pro for this is that it's suitable for very small amounts, and it's easy drainage because it's a basket. There's holes all over it. The con for this is it's incredibly inconsistent, and so as you can imagine, a basket is very small. It's even smaller than what you would get in a heap, and so typically in a basket you're not really doing more than 50 kilograms of beans at a time. And for all the reasons we talked about before, you're going to get high degrees of inconsistency, and you're never going to really attain a consistent fermentation with good flavor development in a basket scenario. But this is more commonly used than not across Asia. And then the last method I want to acknowledge is tray fermentation. And so this can be a really interesting way to ferment. Essentially what it is it's similar to the box fermentation, except for there's multiple layers of very small boxes that are stacked on top of one another with drainage on the bottom. Typically those, the box height is maybe 4 inches or 10 centimeters. And what the pro of this is it allows you to develop some slightly different flavor profiles than you get on a box fermentation. Typically what you'll get with a tray fermentation is some enhanced fruitiness or maybe some enhanced what's called floral notes. And the reason for that is there's a chemical in your cocoa pulp called linalool. And when linalool comes in contact with oxygen, that turns into linalool oxide, which for many of your customers is going to be a flowery or a floral type flavor that is desirable to them. So when we're doing tray fermentation, this is often used to achieve that. There are ways to get that in box fermentation as well. In fact, I'm working with a co-op in Ghana right now to do that. Because one of the cons of using tray fermentation is that it can be very labor intensive. There's lots of lifting of these trays, and trays break because you've got lots of weight on there, and so there's lots of repair that comes along with that. And that if you let your fermentation go for too long, your beans may get very sour. And we'll talk about why that is. But in a tray fermentation, there's lots and lots of airflow because of this bottom open structure. And if you don't have very, very close controls in your fermentation, you can get very, very sour beans very, very quickly. Now, this isn't meant to represent all the ways of ferment, but I'd say this is probably going to capture roughly 90% of the way that fermentation is done around the world. So we're going to switch gears here a little bit and talk about specifically what's happening as you're fermenting your beans. And so when we look at fermentation, we're going to break it up into 4 different sections based on the type of organism that's most active in your fermentation. And so let me back up just a little bit. So this is meant to be a chart that's showing what organism is active at what time in a typical fermentation. And so we're going to go predominantly from a yeast fermentation to a lactic acid to an acetic acid, and then we'll talk about, well, what happens if your fermentation goes too long? And that's going to start to get into some spoilage. But at the beginning of your fermentation, what's happening, or the bulk of what's happening during the first 2 days, are that the yeasts are really, really active. Now, these yeasts are going to be very similar yeasts to what you find in a beer fermentation or in a bread fermentation. And it's just the yeast that's normally found in your environment. This yeast fermentation is what's called anaerobic, meaning in order for your yeast to work, they don't want any oxygen. In fact, oxygen will stop your yeast from working. And your yeast during this anaerobic phase are converting the sugar in your pulp to alcohol and carbon dioxide. Now, in your fermentation pile, remember, your beans at this stage are really, really wet and they're all sticking together. And your pulp is so thick that the only place that oxygen is coming into contact with your fermentation pile is on the outside of your pile. It can't get into the inside of it because that pulp is formed, it's forming a barrier to the inside of your fermentation pile, which is exactly what you want it to do, because that is what's allowing your yeast to be active. Now, as your yeast begins to consume the sugar in your pulp, and it's starting to create that alcohol and that carbon dioxide, your temperature is going to begin to rise. We'll look at some temperature profiles of it, but your fermentation heap can get very, very hot, and that's a good thing. The combination of the alcohol that we're creating and the heat is going to kill your cocoa bean. So at this point, right before this happens, if you take that cocoa bean, and a cocoa bean is just a seed, right? If you take that cocoa bean and you plant it, it's going to grow into a cocoa tree. You don't want to send that to your customer, right? Your customer doesn't want to receive a shipload full of cocoa trees. They want to receive a shipload full of cocoa beans. This first step, you're going to generate enough alcohol that gets hot enough that it's going to render that seed unable to grow a tree anymore, which is a desirable thing. All right, so after this, right, after your yeast fermentation reaches peak, you're then going to start to see a bacteria called the lactic acid bacteria start to increase in its action. Now, this is also anaerobic, meaning that it does not like oxygen. So you can see it's reaching a peak maybe a day and a half or so into your fermentation. And remember, at this point, your pulp is still very wet, right? And so that oxygen can't penetrate your fermentation pile. And lactic acid bacteria, what this is starting to do, it's starting to create some subtle, some low levels of acidity in your cocoa beans. An acid, if you measure it with a pH, is going to be low. So your pH is going to start to drop as your lactic acid is starting to increase. Now, we're going to call, your fermentation is going to create multiple types of acids. And so we're going to break them into volatile and non-volatile categories, meaning can you smell it or can you not smell it? So at this stage, your lactic acid bacteria is going to be considered a non-volatile acid because you can't smell it. It's not going to evaporate. It's important for the flavor of your cocoa beans, and it's going to create a little bit of sourness, not much, but just a little bit. But as you walk by your fermentation, you're not going to be able to sniff it and tell if this is happening or not. You're going to need to use a pH meter if measuring that is important to you. And I'll say for almost everybody listening, measuring lactic acid levels is not going to be important. Your customer may ask about it, but in my experience, measuring it doesn't really give you any benefit in controlling your fermentation. But I want you to be aware that this is a stage that your fermentation will go through. After you go through your lactic acid bacteria, you're going to go to another type of bacteria called acetic acid bacteria, or acetobacter. Now at this stage, and this is 3 or 4 days into your fermentation, by the time you get 3 or 4 days into your fermentation, your pulp, most of your pulp has been eaten away. Your yeast has eaten away most of the pulp. And by this time, you've turned your cocoa mass once or twice. Well, I haven't talked about turning yet, but we will here shortly. And when you turn that, your acetic acid is now considered an aerobic fermentation. Before, they were anaerobic. This is aerobic, meaning your acetic acid needs oxygen for it to work. And so that's the reason it's one of the reasons that we're turning our fermentation piles, is to introduce oxygen into there so your acetic acid has more fuel for it to work with. Now this bacteria is a volatile, or this acid is a volatile acid. You can absolutely smell this. It's going to smell like vinegar or acetic acid as your fermentation is progressing. The more you turn your fermentation heat, the more oxygen you're introducing it to it, and the more acetic acid bacteria activity you're going to have. And so if you're looking to have a very, very sour, or you're trying to increase the sourness of your fermentation, you'll want to turn your cocoa beans multiple times, because that is what's giving your acetic acid bacteria the fuel that it needs in order to create the acid. And we're going to spend a little bit more time on that. But this is also part of the reason why, if you remember the box fermentation, I had holes drilled in that box. What I'm wanting to do is I'm wanting to drain away the alcohol that's formed over here in the yeast fermentation, and I'm wanting to drain away this particular acid as it's being generated. And why do I want to do that? Well, if you've got beans that are just sitting in a pool of alcohol and acid, it's going to make your beans incredibly sour. And ultimately, it's also going to cause your beans to rot. It's going to, other bad things are going to happen with it. So typically, we want your beans to be exposed to some of this. We just don't want them soaking in alcohol and acid for days at a time. This is also one of the reasons why I've got holes drilled into the box. Is at this stage, you've got your liquids, your acids and your alcohols draining out of those holes, but you've now also got oxygen coming into those holes to give some additional fuel for your acetic acid to work with. So these are the main 3 fermentation steps that we're gonna talk about here in further detail in a few minutes. But I also want to acknowledge that if your fermentation goes too long, you're going to start to get into a moldy fermentation. And this is when you know that you've got spoilage organisms occurring. I'm sure any of you who have been fermenting for some time are familiar with this. And typically you'll start with light colors and progress to dark colors. Light colors are I will say, let me be clear that mold is never advantageous. You never want to see mold. Generally speaking, the darker your mold is, the more dangerous it gets. And so there's some serious health things that can come along with mold. We'll talk about that when we talk in the mold section. But this is the overview of all the different stages of fermentation that I'm now going to spend a little bit more time on.
One quick interruption. There are a couple of questions. Somebody asked, the unfermented beans, can you use it for chocolate making process? The cocoa butter from the unfermented cocoa beans, can it be used for chocolate making process? And the second question is, do you add the organisms, or you don't have to, is because they are natural? Those two questions. And somebody raised the hand. Instead, they can just start typing in the chat. That will be better.
Yeah, those are great questions, guys, right? And so let me take the first one. Can you use cocoa butter from unfermented beans to make chocolate? The answer is yes, you can. Now, there's a couple reasons why it's probably not very desirable. And so one of those will be yield. And we'll talk about yield here maybe in 20 minutes or so. But your unfermented bean is going to have lower levels of cocoa butter than your fermented bean will. And I'm getting a little bit ahead of myself, but we'll talk about why that is. But the short answer to your question is yes, you can do that. Cocoa butter also has some flavor to it. And so in the cocoa butter world, there's actually two categories of cocoa butter. There's natural cocoa butter, which is used as is. There's nothing that's done to it, and it comes with some of whatever flavors in your cocoa bean will also be in your cocoa butter. But there's also a category of cocoa butter called deodorized. And what deodorization is think of it as it's almost like boiling your cocoa butter so that any flavors that are in there that you don't like disappear. That's not exactly what's happening, but it'll give you guys the gist of it. And so if you've got an unfermented cocoa bean, remember there's no chocolate character to it at all at this point. And so your cocoa butter is not going to have any chocolate character. It'll probably have some other strange flavors in it that your chocolate manufacturer doesn't want. If you can accept the fact that you're going to get low cocoa butter yields from your unfermented beans, and you want that as your business model, I would then sell those to somebody who's going to extract that butter and put it through a deodorization process, which is going to make your cocoa butter very, very bland. It's going to take away any flavors, or almost any flavors, in your cocoa butter, so that if there are bad flavors in there because your bean wasn't fermented that your chocolate customer doesn't want, that deodorization process will strip those out. Was there another question so it was, do you need to add the organisms or not? That's a great question. The answer is no, you don't. All of these things are just naturally occurring in your environment. And so right now, even as I sit in my home, there's yeast and lactic acid bacteria all around me right now. They're just naturally present. There are some companies who have tried to add those things. They try to make a cocktail and say, here's our special blend of yeasts and bacteria that you could add to that. And it works. There's nothing wrong with doing that, but it's absolutely not needed. It's not necessary. And so why would they do that? Why would they try to create a special cocktail of, if all these things are naturally occurring anyway, why would somebody go through the trouble of trying to create a special thing that they could sell you and that you could add to it? So the short answer is, one, they're trying to sell you something, right? They want you to buy something. There's a commercial element to that. But the higher, the 30,000 foot view on that was that there was a hope that by controlling the specific yeast and the specific bacteria that go into that they could direct your flavor profiles in ways that maybe your local organisms weren't able to do. And there's some truth to that. I don't think it was ever as successful as they hoped it would be, but it does kind of nudge the direction this way or that way a little bit. It's a very expensive way to try to modify your flavor profile. I think in this conversation, we'll find more cost-effective ways to move your flavor profile. And then we're not going to get into this today because this is, this is going to be a more complicated technical conversation, but once we've established the understanding of what's happening at all these stages, there are some other more complicated technical levers that we can pull as a second conversation to try to influence flavor without having to buy a mix of yeasts and bacteria from somebody else. So hopefully that answers the question. Okay, so what I'm going to do now is
one second. Sorry, yeah. One more question. They're asking, the type of wood, does it affect fermentation?
The type of wood?
Yeah, the wood.
Yeah, yeah. That is a great question, and the short answer is it can. Now, I'm not an expert in all the different types of wood all around the world, but I have experienced where instances where wood in one country has given some very, very strange flavor profiles that were unexpected. So we had to change the wood type. So I think that there are definitely some woods that are out there that are going to be better to use than others. If you've got specific woods in mind, I would need to do some research to dig into that a little bit more deeply. Again, I'm just not an expert on all the different trees all around the world. But for the most part, so let me start with that by saying, yes, it can. For the most part, though, my experience has been if you're using a local hardwood, that it almost always works really, really appropriately. Now, what else can happen with a wood where things go wrong? So if you, or maybe cue this up a different way, why would somebody use a plastic box as opposed to a wood box if it's more expensive? What can happen in a wood box is wood is very porous, right? If you cut open wood, you'll see lots of cells and openings, and organisms can get into your wood and live, which is not a bad thing, right? And so if you've got well-controlled fermentations of this yeast and lactic and acetic acid bacteria, those organisms will now kind of become part of your wood. They'll get into those pores and those holes of your wood box, and they'll kind of live there for a while just because they live everywhere. So in effect, after your first fermentation, you'll have inoculated your box as an incubator for these things. So that's not a bad thing. Where it could become a bad thing is if you've got a runaway mold fermentation going on, where you've let your fermentation go for way too long, and we'll see some pictures of this lately. But if your box turns into a fuzzy green mess of mold, that can then inoculate that mold, just like the yeast, is now going to be living in your wood. And you may need to treat your wood or to rebuild your box if you've got a mold infestation in your wood. In plastic, that tends not to happen because plastic is not porous. And we'll look at some plastic boxes when we get to a little bit later, but that would be the downside to using wood, is if you've got a runaway organism in your fermentation that then takes up residence, it's now living in that box, it can be very difficult to get rid of that. And that can then, become part of your future fermentations. Any other questions here, Andal, that I should be answering?
Yes, a couple of more. Somebody is asking, do we have to wash the wooden box? Okay, and then how many, they also want to know, how do we know which stage of fermentation is happening in the fermentation?
Okay, yeah, so.
And then one more thing, they're asking about, this is a specific, I don't know if it's gets into the proprietary or not. Somebody's asking, Valrhona is using banana, and when do you add it, and all those things.
That's a really interesting conversation. So the first one is, do you need to wash your box? No, you don't, unless you've got this, unless your box has gone to full-on moldy fermentation. I would not wash your box. I would keep filling it up and just go back to back fermentations. If you do have that moldy fermentation, then yeah, you probably need to consider probably washing your box with maybe some bleach, because just washing your box isn't going to kill the mold. But generally speaking, no, you don't need to wash your fermentation boxes. What was the second question, Andal?
The second question is, they were asking, the Valrhona, they use banana for fermenting.
Yeah.
They want to know when to add banana. And the next question is, they want to know when its fermentation is going on, how do they know which stages it is in?
Yeah. Okay. Yeah. So let me take the last one first. So how do you know what stage it is? We're gonna actually talk about that in. Let me just jump ahead. Yeah. So if you can hold that for just a couple of minutes, we'll get to that. The short version is I'm going to recommend that you use either a data logger, like something like this, which is going to measure your temperature profile. Or a thermometer where you can just stick a thermometer into it and measure your temperature profile. And if you really want to know what stage you're in, you can also start to measure your pH, because this acetic acid and your lactic acid is going to lower your pH. And so actually, as part of this presentation, I didn't plan to talk about measuring your pH, but if that's important to you, and I've done that hundreds of times all around the world, I've never found it particularly useful for me to do that. I was always trying to find a way to correlate what the pH level was to something that I cared about, right? If I hit a certain pH, do I get a certain flavor? If I hit a certain pH, do I get a certain whatever? I was never able to find that linkage. And so if you're looking to do that, how you would do that would, well, there's a couple ways. The easy way to do that would be with a pH meter. If you really want to get into it, what you can do is either build a microbiology lab or enlist the services of a microbiology lab, pull samples of your cocoa beans at different times and send it off to there and have them tell you what specific types of yeasts and bacteria you have present and what specific species is there. Again, I've done that dozens and dozens of times. I've just never really found a useful way to use that information. But we will talk a little bit more about that in the slides to come. I think the last question is a fantastically interesting one, right? And so I'm not going to talk about what any individual company is or isn't doing, but I think the gist of the question is, can you add fruits to your fermentation and have other interesting things happen? And I think that's a conversation that's probably a couple hours worth of conversation there. The answer is absolutely yes, you can. And so fruits, spices, anything that's going to impart a flavor is going to impart a flavor into your cocoa fermentation. And so typically this is a fairly advanced topic, and there's not a lot of people who are doing this. I think there's tremendous potential here. And so I think the original question was around bananas, but I think I would broaden that to fruits and spices. And so adding fruits, be it a banana or orange or mango or whatever, cocoa is a fruit, right? The pulp around your cocoa seeds is the flesh of the fruit, and it's sugary and has flavor to it. When you add a banana or you add a mango, it's the exact same thing, right? You're adding fruit, you're adding sugar, which is going to give your yeast something to ferment. But then the other flavor compounds that are present, the stuff that makes your banana taste like a banana, or the stuff that makes your orange taste like an orange, now will be incorporated into your fermentation. And some of that's going to get fermented away, but some of that's going to undergo really interesting fermentation chemistry, which is going to change the flavor of your beans. And so I think there's tremendous potential there. I would add that maybe halfway through your fermentation. If you add it all up front, generally speaking, what's going to happen is the sugars that are present in your fruit are going to ferment away. Your temperature is now going to get fairly hot, and we'll look at some temperature curves here in a bit. And you're going to start to boil. You can start to evaporate some of those interesting flavors that you wanted to have into your fermentation. Adding those things later in your process is going to allow them to be present, but at lower temperatures, so that they're for shorter times, so that they're not evaporating. The other interesting thing that you didn't ask about, but I think is worth just acknowledging, is putting the spices into there too. And so Spices, it's not going to really matter when you add them. I would add them earlier as opposed to later. Again, not many people are doing that. But if you wanted, I'm going to make something up here. If you wanted hints of cinnamon in your cocoa beans, adding some cinnamon bark, right? Cinnamon comes from the bark of the cinnamon tree. Adding some cinnamon bark, grinding it up and adding it early on, so that as you're turning your fermentation over and over, it's getting mixed into your beans, could be a really interesting way to modify your flavor of your cocoa beans in ways that not many people do it. So I think those are all fantastic questions, guys.
Quickly, two more on this point. When you add the spices, will it kill the microorganism? And the other one is asking, do we have to measure the Brix before the fermentation?
Yeah, great questions. And so, I think that the difference between medicine and poison is the dose, right? And so if you're trying to ferment 300 kilograms of cocoa beans, but you're trying to add 2,000 kilograms of spice, yeah, it's probably going to kill your organism. I think a little bit goes a long way with spice. And so, I would start with very, very low levels. And again, let's use cinnamon as the example. If you're looking at cinnamon, I would start with very, very low levels of cinnamon. If you've got 300 kilograms of beans, well, maybe you want to start with maybe a couple hundred grams of cinnamon, right? At those low levels, you're not going to be killing your microorganisms. You should, a watch out though with spices is that if you've got wooden fermentation boxes, your spices, your wood can take on the character of your spices as well. And so if this week you're trying to do a fermentation with cinnamon, and next week you want to do a fermentation without cinnamon, but you're using the same box, well, even though you didn't put any cinnamon in the fermentation next week, because your cinnamon is now penetrated the wood of your box, what comes out next week is probably going to taste a little bit like cinnamon. And so just be aware that as you're working with spices, that your box can take on some of the character of those spices, whether you want it to or not. So you may want to dedicate boxes for certain types of spice fermentation if that's the road you're going down. And so for the next question was about Brix. And that is what we're going to talk about in the next slide. So hold that one and we'll talk about Brix. But anything else on fermentation before I move to the next topic?
We don't see any other questions on
fermentation. Okay, those are really good questions, guys. So now I want to spend a little bit of time talking about, now that we understand the different phases of fermentation, well, what are the top things that I want you to take away for what's important? And so for your first fermentation, the very first thing is you have to have good quality beans coming into your fermentation. And so part of that means making sure you have mature pods. And so if you harvest unripe pods, what you're going to get is something that looks like this. We saw a picture of a cutaway pod a little, when I started, that showed, beans with good separation and lots of slippery, juicy pulp around there. This will turn into that. But at this stage, because this is an immature pod, this starch has not, the enzymes in your cocoa pod have not yet turned these starches into sugars, which are going to be able to be fermented. And so if you put this into your fermentation, for your fermentation, all of this is going to come out as a clump. You're not going to get good separation of your beans. Your beans are going to be really, really small. They're going to be flat, and they're going to be low in fat. And they're not going to ferment, right? Because none of this are very low amounts of sugar here. And so if you've got immature pods going into your fermentation, that's just going to be a problem. It's going to create a very low quality product for you. And I say that because in many parts of the world, people treat their cocoa trees almost like the bank, right? And they go, all right, I've got a festival coming up next week. I need some money to go buy food for the festival. I'm going to go pick everything on my tree, whether it's ripe or not, because they get paid by weight. Well, when you do that, that's great if your cocoa, if your fruit is ripe. But if it's coming off like this, really what that's going to do is create something that's unusable in the chocolate world. This is really what you're looking for, right? So you've got all that starch is now turned into sugar. This is going to be slippery to the touch. If you taste it, I'm sure most of you have tasted cocoa pulp. It's delicious. It tastes almost like a melony sweetness. All this is going to be a really good sign that you've got material that's ready for fermentation. Now, to come to your question on a refractometer, how can I objectively, right? What's the scientific measure that I can use to say, all right, well, this looks good, but how do I know that it's good from a Brix perspective? So what Brix means is it's a measure of how much sugar, or actually it's a measure of how much solids are in a liquid. And we're going to use it to be a measure of how much sugar is in your pulp. And so if you take these cocoa beans, and how you measure that is with something called a refractometer. So this is my personal refractometer. This is what it looks like. When you look through it, you'll see something like this. How you use it is you take your cocoa pulp, pick it up in your hand, squeeze it. When you squeeze it, it's going to go drip, drip, drip. You put that drip, drip, drip kind of on this little glass plate right here. Close this up, and it's going to smush. It's going to smash that liquid into a flat layer. And then you look through it, and when you look through it, what you're going to see is something that looks like this. What's happening is the light from around you is coming into this. It's being bent a little bit by how much sugar is on the juice that you just put onto here, and it's going to give you a reading of what your sugars levels are. So for here, this is telling us that whatever material is put on here has a sugars level or a Brix level of 30. Now, you're never ever going to see a Brix level that's this high in cocoa. Typically, what you're going to see is in the 10 to maybe 20 range, 25 maybe. 25 would be an exceptionally high level of Brix in cocoa. But what we're looking for is as your wet beans are coming in, one of the things that I recommend that you do is to assess your pulp using a refractometer. And really, what you want to do is have this line be at least at the 13. That's telling you that 13% of the juice that's coming out of here is sugar in it, and more is better. Remember that the sugar is the fuel for your fermentation. And if you've got low sugars, it's either because your pods are immature, it could be that your pods were diseased, and we'll talk about disease in the next section here, or, and I've seen this happen a little bit, is that if you've got farmers who are not fermenting their own beans, rather they're selling their beans to somebody else to ferment, those farmers are paid by the weight of their beans. And so what they'll often do, I'm sorry, not often, what they'll sometimes do is after they've put all their beans into a bag, they're carrying it over to where they want to sell it. Sometimes they'll add water to it, and water adds weight. And so if they're being paid strictly on the basis of weight, water weighs a lot, right? So just by looking at your pod or your beans, it's very difficult to tell if somebody's added water to them or not. This Brix test will help you understand if that's been watered down or not. Because if you add water to it, let's say we started at 13 Brix. If you add water to it, that's going to dilute it, and now it may be reading 8 or 9. So it's a good measure to let you know. You may not know why you've got low sugars, but you'll at least know that you have low sugars. And then you can figure out, do you want to accept and ferment those beans or not? Or do you blend them with something that's much higher in Brix? So a good strategy to say, all right, if I've got 2 batches of beans, this one is low in Brix for some reason. Nobody knows why, but it's low. And this one is very high in Brix. Well, you can blend those 2 things together. So now that the average of their Brix is something that's going to be at least 13 or higher. Okay, let me just stop there for a second and just see if there's any, if that answered the question on Brix.
Yes, there is one more question on Brix. Somebody is asking, does draining the beans in the bag overnight before putting in the fermentation boxes impact Brix measurement? In Dominican Republic, wet beans are measured by volume at the farm gate.
Yeah, so draining the beans, the wet beans at night will absolutely impact the Brix. So why would somebody do that? So earlier on we talked about if you take this bean right here, right, for example, and you cut this bean open, chances are pretty good it's going to be purple. It may be white, but 95% of the time it's going to be purple, because of those flavonoids that are in there, those heart healthy chemicals that are in there. If you want to retain as much of that as possible, one of the strategies for retaining that is to produce a low Brix fermentation. So the combination of alcohol and acid and heat are all going to result in lower levels of those purple flavanols from surviving. And so some people may be draining their beans specifically to get to lower levels of sugar so that your fermentation doesn't progress as vigorously. It doesn't create as much acid. It doesn't create as much alcohol. It doesn't create as high temperatures so that they can retain, you know, more of that than they would otherwise. It's not a very common thing, but that would be one reason for draining your beans before fermentation. Okay. If there's no other questions on that, I'm going to move to the other thing that is really critical at this stage, and it's ensuring that your beans are disease and damage free. And so because your cocoa pod is a fruit and the inside of your fruit is just delicious, bugs and birds and other organisms want to eat it too. Now your pod is intact and sterile until it's been opened. And so unless something pierces the shell, right, unless a worm crawls through it, or unless a woodpecker pokes a hole into it, nothing's going to happen to the inside of your beans until you open that shell. Now, unfortunately, lots of things want to get into that shell, right? Rats will eat it. Black pod or frosty pod or cocoa pod borer will all result in penetrating the hull of your skull of your pod and spoiling the beans from the inside. And so here's examples of, you know, I think most of you probably recognize disease beans, but this is what's happening, or disease pods. This is what's happening on the inside of that. And your sugars are being eaten away. So you're going to get low, you know, a low Brix or a low sugar fermentation with this. But something else is happening here is the cocoa fat, the cocoa butter that's in your beans is also being affected. And what's happening is it's turning it from good tasting fat to bad tasting fat by creating something called free fatty acids. And we won't really talk a lot about that because there's nothing you can do about that. But the important takeaway here is that it's really helpful if you've got a screening protocol in place so that as these things are found, right, either you've got immature pods coming in because somebody's always going to pick an immature pod, or as you've got disease beans coming in, that you've got some way of removing those from your fermentation, because these are all going to create pretty significant problems on your finished product side for your customer. Here's an example. I think this was probably in the Dominican Republic where I took it, where a woodpecker just, you know, poked a hole in here. But now you can see anything can get into there. The yeasts that are in the air or insects can get into there and start to essentially rot the pod from the inside out. All right, so based on what we just talked about here, here's a heat fermentation in the Ivory Coast that I took. Looking at this pod right here, can you guys do you guys see any problems with this, or what do you see here? I kind of want to open the floor to have you guys talk to me about if you think this is a good fermentation pile or a bad one, and why do you think that is?
Okay, people are saying mixed good and bad beans, mold, discolored patches, black spots are coming from damaged parts, and yeah, those are my.
Yeah, that's spot on, guys, right? And so what I see here is you know, lots of black pods coming here. So there's lots of diseased pods that are trying to be incorporated into here. I see some brown over here, which is not a bad thing, but this tells me that these are aged beans, right? So those were taken out of their pod probably yesterday, and the fermentation, or 2 days ago, and that fermentation is already well underway. They're starting to brown. And what I see here are beans that are not separating. And so we've got some immature pods being mixed with clearly diseased pods being mixed with beans that are of considerable age versus the fresh beans. And so this pile is going to be a pretty rough fermentation. This is not going to produce something that is high quality. But again, if we go back to that saying in the Ivorian saying of there is no grave for cocoa, and if your farmers, you're paid on weight, right? So you're trying to find ways to maximize your value. You maybe want to think about separating your low value beans from your high value beans, keeping your high value beans for selling to customers who are using them for flavor purposes, like chocolate, and taking your low value beans and selling them to customers who are pressing them for butter, where they may not be, flavor may not be important. But good eye. I think you got all the things that I was looking for there. So nice job.
Yeah, somebody is asking one more thing, sorry. What's the optimum period from harvest to cutting the pods before fermentation? And then the another one is asking, can you discuss what to do with the opened pods, recommendation for discarding them?
Yeah.
The shells, I think they're talking about the shells of the pod.
Yep. So the first one, what's the optimal time? What I like to do is I like to harvest pods during the day. I like to open them when it's hot, right? I like to harvest during the day. I'll create, a pile of pods for us to open later. Harvest these in the morning or early afternoon, and then by the time it gets to early evening, start opening them. And so, why do I do that? Well, remember that as soon as you open up your pods, fermentation begins. And so typically what I like to do is start my opening of the pods towards the end of the day when things are starting to get cooler. Because what's often going to happen is I'm going to transport those wet beans to a large area, a large fermentory where they can be fermented. I want to avoid this, right? I want to avoid random sizes of piles throughout the jungle and having hundreds of them all of different sizes. And so I want to bring them to I want to bring the beans from 50 or 100 farmers together where I've got standard boxes where I can ferment them, because now I'm going to get consistency. And if I'm transporting those things at night, fermentation has started, whether I wanted to or not, right? I've opened up the pods and yeasts are falling on them. Fermentation has started. If I transport those at night, it's now cooler out, and the fermentation is going to happen more slowly than if I were trying to transport them during the heat of the day. Now, what to do with the pods? And this is a really, really good question, and I was going to talk about that a little bit later, but I think I'll just jump to that now. So oftentimes in many parts of the world, what you've got, most farmers aren't fertilizing their soil, right? And so if a cocoa tree lives for 20 or 30 years, what it's doing as it's producing its fruit is it's pulling up nutrients from the soil in order to make its fruit. Well, if you've never added any more nutrients to your soil, if you've never fertilized your soil is now going to be depleted, right? And so if this has been happening for generations, your tree doesn't get the nutrients it needs. And as a result, its productivity is going to suffer. Its quality is going to suffer. So it's not producing as many pods as it would like to. And the pods that it is producing aren't going to be of the weight that they could be, just because your soil has been so depleted of vitamins and minerals. So an easy way to think about how can you start to better that is, this pod right here. So your average tree will pull something like or your average farm will pull something like 60 kilograms of potassium out of the soil over its lifetime. And potassium is a critical mineral for tree growth. And most of that potassium is going into the pod of the shell, right? And so it just gets, in many parts of the world, it's just being thrown away. Really what farmers are after is this, and they forget that there's value here. So what I'm a big fan of is I'm a big fan of taking these pods, because this is about 60% of the mass. Right? You pull your pod off the tree, 40% of its weight is here, the other 60% is here. Well, if you can take that material, it's all organic material, and if you can slice it up into small pieces, compost it, and then use that as fertilizer to go back to the soil, now you're adding nutrients back to your soil. And it doesn't solve the problem, because ultimately, most farms, it's been 30 years without fertilizer. But if you can get in the habit of taking your organic material, right, your and most farmers aren't just growing cocoa, they're growing bananas or they're growing something else. If you can take all of your extra organic material, your shells, your banana leaves, your husks, and find a way to compost them, you've now got a valuable fertilizer that you can come back and feed to your trees by burying that in the soil around your trees. What I'm not a fan of picking the pods, like this pod here, and then transporting it someplace else. I know lots of people do that. I personally don't like that. Why don't I like that? Well, if you've got, so this farm clearly has a disease problem, right? We can see there's black pods all over the place here. If there's a disease problem in your farm, most of those diseases are, they start on the outside of your pod. And now if this farmer is taking those pods and he's moving it through other farms, he's now increasing the likelihood that he's going to infect other farms with his disease. And now you've got a regional problem as opposed, your neighbors all have a problem instead of you having a problem. So I'm not a fan of picking pods, moving them someplace else to be opened. I'd rather see them opened at the farm, composted at the farm, and then that material be fed back into the soil. Any other questions on that? Great. So on immature pods, this is a study I did in, I think it was Indonesia, to understand exactly what's happening if there's lots of immature pods into your fermentation. And so you can see these are all immature pods that, we can tell they're immature because the beans are flat, they didn't separate. I intentionally added different levels of immature pods for my fermentation heap to understand, well, exactly what's happening there. And the short version of it is that just bad things happen. Your customer is not going to be happy with this at all. You're going to have serious flavor problems. You're going to have small beans that they're not going to be able to take the shell off and winnow, and they're going to be very, very low in fat. All of these things are going to be things that that's going to make your customer not going to want to come back and buy your beans from you again. Okay. And this is just recognizing that each day your beans are going to look a little bit different, right? And so if we start out with very wet beans early on in your process, by the time you get over here, you can start to see that, that as that pulp is fermented away, whereas you couldn't, there's no holes in your beans for oxygen to get in over here, you can start to see that as that's drained away, now you've got the ability for oxygen to kind of work its way in. And your beans are starting to change color, right? And so they're going from, you can't see the purple here because it's coated in white pulp, but as that pulp drains away, you can see that your beans still early on have a high degree of those flavonols left in them. They're still purple, but by the time you get, completed with your fermentation, for the most part, and it's called browning, cleverly named a browning reaction because it turns things brown. But there's some chemistry happening there that's called browning reactions that are changing the color of your beans. So you should expect your beans to look different as your fermentation progresses. So somebody had asked, well, how can we measure? How do we know what stage that we're in? And for me, it's less important about knowing the stage you're in and more important about knowing, is your fermentation doing what you expect it to do? And so we talked about fermentation is creating a bunch of things. One of those things is heat. And so here's a temperature profile of two things. The red line is just a temperature profile of outside. Like, what's the temperature outside doing? And this is a temperature profile of what's happening in the box of beans itself. And so we can see that as we're going, the temperature is increasing. By the time we get maybe 2 days in or so, we've hit our peak temperature. So this is as warm as it's going to get. And now it's starting to cool off. Where we see these drops and these spikes, this tells me that our beans have been turned. So immediately after we turn the beans, we see a spike in temperature. They're turned here again, and we see another spike in temperature. Remember, when we turn our beans, that's putting more air, more oxygen into your pile. And at this stage, we're at the latter stages of a fermentation. This is the acetic fermentation phase. And oxygen is fuel for your acetic fermentation. So we put a bunch of oxygen in there. The acetic bacteria go, yes, I've got more things I can do stuff with. They start being really, really active, and they generate a lot of heat. And so by understanding, if you've done some fermentation, and let me jump ahead here a little bit. Here's a specific fermentation profile I did out in Asia someplace. And I took a data logger. Now it wasn't this data logger, but it was something similar to this. And I put it in the middle of my fermentation. And I told it, I want you to take a temperature reading every single minute of every single day until I'm done. And I did that 519 times. And so what this is telling me, this is a plot of all that information. The green line is what the average temperature is. And anything above the green line is how high did it get? And anything below the green line is how low did it get? So how do I use that? And right here, you can see where I turned it, right? And so I turned it, I mixed it all up, the temperature drops because like you spread the beans out, and then immediately the temperature jumps back up again because you put all that oxygen back into it. So why do I do this? I do this because I want the ability to say, all right, if I'm happy with the beans that this is giving me, right? This fermentation gives me something that I like, but more importantly, my customer likes. I don't want to have to put a data log in there every single time. That's just overkill. What I want what I want the ability to do is to say, all right, at 24 hours or 48 hours or 72 hours or whatever my time frame is, I want to be able to walk by that box, just stick a thermometer in there. And if I know, and I know that as long as my temperature is anywhere within this range, my fermentation is doing what I expected it to do. Okay, so it doesn't tell me which stage I'm in, although I know early on, just because of the chart we looked at before, at 24 hours, I'm still squarely in my yeast phase, but that doesn't help me control my fermentation. What I do want to know is my temperature doing what I expected it to do? So as you think about putting quality control procedures in place in your fermentation, monitoring your fermentation profile so you know what good looks like, and then having a thermometer that you can stick in there every once in a while will help you understand, is this doing what I expected it to do? Okay. So turning the beans, and I've referenced this a few times now, it's just a function of moving your beans from one box to another box, or spreading out your fermentation heap and then remaking another heap. Its purpose is to put more oxygen into there so your acetic bacteria can get the fuel that they need to do that. And it allows for uniformity of fermentation. So if you've got your fermentation heap and you never do anything with it, right? You just let it sit there for 5 days. What's on the inside of your heap is going to be very different than what's on the outside of your heap. And so every once in a while, we want to get that mixed up so everything is being exposed to similar conditions, and we don't have, let's call it a gradient of fermentation from the inside, from the outside in. Let me just stop there a little bit and see if that, what questions you have on either turning the beans or temperature profile, and using temperature as a metric for understanding if your fermentation is doing what you expected it to do.
Okay. When you use the term sour, is that bitterness? And the next question is, how many times do you have to turn the cocoa mass?
Yeah. So sour is not the same as bitterness. Sour is, I don't know how to explain it. Sour is sour, right? So it kind of makes you pucker your lips, and it's like biting into a lemon. Bitterness is something very different. Bitterness is not going to have any sourness to it. One of the difficult things in talking about flavor over the computer is it's difficult for everybody to have the same meaning, right? And so usually what we would do is I would take, let's say, I'm working with you. I would take beans. I would send you these beans. I would keep these beans to myself, and then we would get on Zoom and we would taste them together and say, all right, this bean is sour or this bean is bitter. So that then we're tasting the same thing at the same time and talking about the same flavor to make sure that we're not using, that I'm not saying bitter, but you're thinking sour. So that's probably the best way to talk about making sure you understand the same thing. But bitter is very different than sour. Sour is always going to be driven by an acid of some sort, right? So it's an acetic acid. We talked a little bit about lactic acid. There's another kind of acid that shows up called citric acid. But at the end of the day, sour is always going to be because you've got acid in there. And then the second question, Andal, was how many times should you be turning?
Yeah, how many times do you have to turn the cocoa mass?
Yeah. So there is no right answer to that. One of the one of the things that I want you to take away from this is that you can customize your fermentation to create lots of different types of flavors. And so if you want a flavor that is, if your customer wants a flavor that's more sour, you're going to want to turn your beans frequently. And so what you may want to do is, and I'm going to just make this up as an example, you may want to have a 5-day fermentation where you turn that bean every single day for 5 days, because that's going to put a lot of oxygen into your mass and is going to make sure your acetic bacteria are really active and create lots of acid. Or, and most people don't want a really sour fermentation. There's a couple, but most people don't. If you don't want a sour fermentation, what you may do is a 5-day fermentation with maybe 1 or 2 turns in it. It is important to turn your beans because, again, it's not just about putting oxygen into your fermentation mass. It's also about making sure that the beans are mixed up so that they're all being given the chance to ferment similarly. So there is no one right way, but what I want you to take away is the more you turn the beans, you can create a range of sourness from, you turn it once, it's going to be, not very sour, to twice, to 3, to 4, to 5 times. And each time you do that, it's going to get increasingly more sour. So you now have the ability to go to your customer and say, what type of flavor are you looking for? And if they're indicating they want something that has moderate sour, well, then now maybe you're turning it 2 or 3 times. If they want something that is minimal sour, maybe you're turning it once. If they want something that's very sour, then you want to turn it every single day. And it gives you the ability to customize your fermentation to create multiple types of products.
Okay, the next two questions are: anaerobic fermentation, is it 24 hours or 48 hours? And then when to make the first turn of the beans, and then the drum fermentation.
Yeah, so let me go back to that slide where I was talking about. So all of this is going to be happening at some level all the time, right? And so it's not exactly at 24 hours anaerobic starts or stops, right? There's always going to be a little bit of these things happening at the same time. When I talk about the first one being this anaerobic yeast fermentation, it's because that's the predominant one. That's the one that is most active and the one that's really driving the main activity. Although, as you can see from here, there's some acetic acid bacteria present, right? Because on the outside of your pile, there's acetic acid, and because the outside of your pile is where the oxygen is, there's going to be a little bit of acetic acid bacteria activity happening. Same thing for lactic acid. What's going to happen over time is that your predominant phase is going to shift away from yeast and into lactic, and then it's going to shift away from lactic and into acetic. And so all of these things are happening simultaneously. But when we talk about this going to this, it's not about it's 100% this, which then stops, and then goes to 100% this, which then stops. There's some degree of all of these things happening simultaneously, but really predominantly early on, this is the one we're most concerned about. It then changes to lactic acid, even though there's still some of the other ones happening as a predominant one, and then changes to acetic acid as a predominant one. And I think there may have been a second part of that I didn't answer, but I forgot what the question was.
When to make the first turn?
Yeah. So it's again, there's no one right answer to that. It's about customizing your fermentation profile. Very commonly, the first turn happens at about 24 hours. Now, there's no magic there to say it has to always happen at 24 hours. I've had some where I've done 8 hours, or I've done some where I've done 16 hours, or some where I've done 30 hours. And so there is no one right answer. Depending on specifically what the flavor profile you're trying to achieve is, we can move that one way or the other. What is important though is and again, I'm going to make something up here. If you decide that you want to do your first turn at 24 hours and you're happy with what you get, right? You decide that you want to do one turn at 24 hours and another turn at 72 hours, and you're really happy with that, then for subsequent fermentations, do that exactly every time, right? So what I don't want to see happen is is, all right, we're happy with turning at, at 24 and 72 hours. And then next time we go, well, it's 20 hours, it's close enough. I'm going to turn it at 20 hours. That's going to bring inconsistency. It's now going to look, different than it did when you turned it at 24 hours. And so there's no one right answer to exactly when is the first turn. 24 hours is a pretty common first turn. Although you can certainly do it before, you can certainly do it after. And you have to play with that a little bit to figure out, are you getting exactly what you want to get? But once you are, make sure that you've got some sort of mechanism in place to ensure that if you turned at 24 hours the first time, that every fermentation after that gets turned at 24 hours. Otherwise, you're going to start to get, different weird things happening. Okay. Unless there's any other questions, I'm going to keep moving. So here's some examples of how people turn beans at larger scale. And so these are two types of fermentations. This is a 5-day fermentation. We can see what we would do is we would load the boxes at the top, and then after, once a day, we would turn it from this box to this box, and then the next day from this box to this box. Again, these front doors, these front panels just lift up. And so you don't have to shovel over the top of it. You can just remove this front panel and push your beans into the box below it, and let gravity do the work for you. It's a real time saver. And you can see that there's holes drilled in all these, right? And so we can see that the liquid's draining out of that, and it gives the opportunity for oxygen to come back into that. This is one we had set up in South America, and here's one I had set up in an island in the Caribbean someplace. And here we used plastic boxes because it was funding was, they had the money to do plastic boxes, and so we did plastic boxes. This is a 3-day fermentation, right? So we will load at the top box, and then 1 turn, 2 turn, but it allows for 3 days, and then we're done. One of the so the step layout is definitely a labor saver. You don't want to put these boxes just at the same level and have to shovel up out of the box into the next box. I've done it plenty of times. Trust me, you just don't want to do that. It's more work than you probably want to do. Having this tiered mechanism is a great way to save labor. It's just easier to let gravity do the work for you. It's also important here to acknowledge that over all these, I've got a roof, right? And there's a couple of reasons for that. One, without the roof, the sun just shines on it. And if the sun is shining on it, now you've got lots of variability being introduced because the sun is going to heat up your beans. And now your fermentation is going to do something different than if the sun wasn't shining on it. If it gets really, really hot, your fermentation could kill the top level of your yeasts and molds, yeasts and bacteria. Or if it just gets really warm, it'll make things happen faster. And so faster isn't necessarily bad, but if we've got the sun today and no sun tomorrow, now we've got inconsistency, right? And so we want to have some sort of cover over your fermentation boxes to shield it from not only the sun, but also the rain. And so as you can imagine, if these are just sitting out in the open and it rains, well, you've just diluted all your sugars, and all your sugars are running out. And again, you've got, and you've cooled your fermentation because the rain will cool it down. So having some way to cover your fermentation, keep it out of direct sunlight and rain is helpful. So based on what we've talked about, guys, right? We've got a 5-turn fermentation here and a 3-turn fermentation here. Both of these are about 600 kilogram fermentation sizes. Both of these have holes in the boxes. Which one of these would you expect to produce a more sour bean, and why? So I'm going to put that question out to you and let you tell me the answer.
Left side.
The left side? That's correct. And why would the left side be more sour?
Much more times turn.
Exactly. So more times turn means more oxygen getting into your fermentation, means more acetic acid bacteria fuel, and you're going to have more acid produced. Exactly. Nice job. Okay. So earlier we talked about, I think the question was, what happens to unfermented beans? Can they be used for anything? And I referenced the fact that your unfermented beans are going to be lower in fat. And let's spend a little bit of time on this, because this I often found that this concept can confuse people. So the natural fat in your cocoa beans is something that your chocolate customer is always going to want, and more is always going to be better. Now, one of the reasons we ferment, the primary reason we ferment, is because it gives us nice flavors. But a secondary reason that most people aren't aware of is it also increases the fat in your beans. Your fermented beans are going to have higher levels of fat than your unfermented beans. And if your beans are low in fat, now your customer has to add cocoa butter back to their formula, which is very expensive. They would rather get their cocoa butter through their cocoa beans because it's a less expensive way for them to do that, which means that can be valuable to you. So if you can generate beans that are higher in fat, there's value in that to your customer because they don't have to buy the more expensive cocoa butter. So why is that, right? So if we've got, and it looks like on my screen, I've got some kind of weird text here. I'm not sure what that is, but your unfermented beans are predominantly made up of three things, right? You've got fats, which is your cocoa butter. You've got sugars, which are your starches, and you've got protein. And these are the three building blocks that are the main things that are found in every food that we eat. So if all these things are present in more or less equal ratios in your unfermented beans, and we know that fermentation eats your sugar, right? So in this instance, we've got a fat content in your unfermented bean of about 1/3, it's about 33%, right? So we got 3 circles of fat, 3 triangles of sugar, 3 squares of protein. 1/3 of your bean is fat. Well, when we go through fermentation, all your sugar gets consumed, right? Your yeasts are eating your sugar, which means that on this side, by the time we get to fermented beans, you've still got the 3 circles of fat, you've still got the 3 squares of protein, but there is no sugar anymore. So as a unit, now this is 50% fat, not because we've created more fat, but because we've consumed the sugars that were in there, resulting in this bean over here being higher in fat than this bean. Okay, so does that make sense to you? So if you're trying to sell your unfermented beans for cocoa butter, this is going to be, you can do that, and there are people who do that, but it's a lower value stream to your consumer who's just pressing the beans for butter because it's only 1/3, right? Their yield is going to be low. They're not going to get as much cocoa butter out of that as they would as getting cocoa butter out of this. Okay. So I don't want to spend a lot of time on that, but I want to make sure that it's understood that your cocoa butter level is a component of this. Mold. So very briefly early on, we talked about the 4th stage of fermentation being mold. And so this is something you don't want to see. This is not a particularly bad moldy fermentation. It is a particularly bad picture. For that, I apologize. I don't remember where I took this picture. It must have been a long time ago. But you can see that around the edges here, we're starting to get some white mold. So this tells us that our fermentation has gone too long, right? So this typically will start to occur at 6 to 7 days. And generally speaking, we don't want to see any mold, right? Mold is always going to result in a negative of some sort, ranging from flavor. So a little bit of white mold is going to create, all your molds are going to create poor flavors. And if you've got moldy flavor, that cannot be processed out. So there are some flavors that when you sell your beans to your customer, if they don't like the flavor, there are things they can do in their roaster or in their treatment systems to remove the off flavors. Mold is one of the flavors that is just not going to be in the capability of most of your customers to remove. It can be done. It's a trade secret. It's very difficult, it's very complex, and most of the world doesn't know how to do it. So that means we want to avoid that. White mold is typically not dangerous. It's not going to be a health concern. In fact, lots of places eat white mold on purpose, right? So if you're eating cheeses or cured meats, oftentimes they'll have penicillium molds on there because it's a desirable trait for those things. But this is neither a cheese nor a cured meat, so we don't want to see any mold on here. If this goes too long, this is going to start to change colors. So you're going to get red and green and black molds. And generally speaking, the darker your mold, the more ability it has to produce toxins. And so your darker molds will start to create things called aflatoxins, which are among the most poisonous substances on the planet. There's 4 kinds of aflatoxins. We won't go into them, it doesn't matter. or they could start to create something called ochratoxins, which are again very they can be deadly. And so we want to avoid mold as much as we can. And if you've ever got dark molds in your beans, those are something that you want to make sure that just gets destroyed. If you've got a little bit of white mold in there, and that's not unusual, I wouldn't get too concerned about that. It'll if you've got, looking at this, it's maybe 1 or 2% of the fermentation heap of white mold. This is not going to be a significant problem from a flavor perspective, but if it progresses past that, it will be. Anything that's a dark mold needs to really be destroyed. Absolutely do not ingest that. It could easily kill you. And so here are some examples of fermentation where it has gone to significant green molding. And again, these were done on purpose to really understand at a molecular level what's happening when your beans are molding. In addition to, mapping the specific toxins and the levels that they're produced, what the mold is doing is it's tearing apart the cocoa butter in your bean, and it's breaking it down into its building blocks called free fatty acids. And those free fatty acids are typically what, if you've ever had some fried food that tastes rancid, for example, you're tasting some free fatty acids that are in there. And so these molds will not only produce poisons and carcinogens, but they'll also create rancid oil flavors for the most part. And this is a pretty extreme level of molding here. You can see it's in a wooden fermentation box. This box probably is going to need to be, well, it was destroyed. We tore it apart and we burned it, because at this level of molding, there's so much mold living in the pieces of wood now that that wood now becomes an incubator for mold, and the next fermentation we put into there would simply become dang it, not sure what's going on with my mouse. Sorry, let me just try to clean my mouse here. That fermentation then becomes a point contamination source of mold for your next fermentation. And we're not really going to talk about drying today, but that might be a good follow-up conversation, is that after you ferment your beans, drying is a critical step in making sure you've got suitable quality beans. As much can go right or wrong with drying as can in fermentation, and how you dry can influence your flavor as well. And it can be really easy to think that your beans have been suitably dried, and then they may look like good dry beans, but if you don't have a piece of equipment to tell you what the moisture level is, you may mistakenly think you've got good beans, put them into your export sack, and then a month later when your customer opens it, because your moisture may not have been as low as you thought it was, you now have molding that occurred in the bag, and this is all going to be rejected and destroyed. So having some way to test your moisture of your beans is going to be really helpful. Again, this is not a drying conversation, but one of the pieces of equipment that I use, I brought this all over the world, is produced by a company called Dickie John, and it's called a Mini GAC Plus. And so essentially what you do is, on your drying table, when you think you've got to the moisture that you want, it looks like a coffee brewer, right? You fill up the inside of it with your beans, you push a button here, and 20 seconds later, it tells you what the moisture of your beans is. It's really easy to use. It's really durable. It does cost a couple of $100s. And so for many farmers, that's a big ask to purchase. But if you're working as a cooperative, right, of 300 farmers, if every farmer can put $1 in, well, now they've just subsidized the purchase of a piece of analytical equipment that can guarantee that your beans are sufficiently dried. And what you're looking for is a moisture level between 6 and 8%. Again, this is not meant to be a drying conversation, but that's an important part. Sorry, was there a question?
的是在这边呢，或者是给它转过来这边呢，它的投影的东西的，是在冷啊。
I apologize, my 我会说普通话一点儿 is not that good. So if you could type your question into the chat, that would be helpful. We can come back to that if we need to. So what I had done is I had tried to anticipate some questions that I thought folks might ask and give my perspective on that. And so I think we answered this one earlier. What's better, fermenting at the farm or the fermentery? I think I talked about that earlier. I'd rather do it at the farm, or I'd rather ferment at the central fermentery, but open the pods at the farm and transport them. And this is what number 2 gets into. And so I don't like transporting pods. Many people do it, but I think that when you do that, you increase the likelihood that you're spreading disease through your region. Best type of fermentation, again, there is no best type. I lean very heavily to boxes because they give me better control, right? I can standardize everything. I can standardize their size. I can standardize the fill weights. I can standardize how much drainage and how much turnability is. And what that gives you is a standard product for your customer. And boxes also give a high degree of flexibility if you wanted to create multiple product types. So I'm personally a big fan of box fermentation. To drain or not to drain, I think we talked about that as well. It all depends on the flavor profile your customer wants. I am a big fan of the drainage holes because it reduces the amount of time that your beans are now sitting in the liquids that your fermentation is creating. It reduces the amount of soak time in acids. It reduces the amount of soak times in alcohols. Both of those things are necessary and they're important. We just don't want your beans soaking in them for days at a time. Why do beans look purple or brown inside? I think we talked about that as well. So that purple comes from that heart-healthy compound called flavonoids. And we can adjust our fermentation process to create a range. If we want to retain those things, we're going to ferment for shorter periods with fewer turns. If we want to not have them and really focus on flavor, we'll ferment for longer times with maybe a few more turns on it. And again, this is not meant to be a drying conversation, but it's difficult to talk about cocoa beans without talking about drying to some extent. One of the things that I would suggest that you do is to do cut test as a measure for, is your fermentation doing what you expected it to do? And so we talked about using temperature to figure out, is your fermentation progressing as you want to? That's an in-process, sort of test point. After your beans have been fermented and dried, there's a real good opportunity to look at your beans again and say, did this do what I was expecting it to do? Did this turn out expected? And how we do that is we cut our beans in half. And so this here it's called a Magra book cutter. And what you do is you put 50 beans into it, close it, and then there's a knife that cuts them in half. And when you do that, you can very quickly look at your beans and see, are they purple or brown? And so in this example here, right, we see maybe 80% purple and maybe 80% brown and maybe 20% purple. And this is telling me that this particular fermentation wanted to maintain a certain amount of those flavanols while developing some good chocolate character as well. And so how I would use this is I would say, all right, I want no more than 20% of my beans to be purple when I do the cut test. I then take those beans off of my drying table. I will have measured the moisture with this or some other tool to know that the moisture is stable. They're dry enough that they're not going to mold. And then I'll cut 50 or 100 beans in half, and I'll set my internal specifications. If I don't want any purple beans, I don't want to see any purple beans. If my expectation is I'm not going to see any purple beans, but now I see 20% purple beans, well, then something happened in my fermentation that was wrong, right? I forgot to turn, I didn't turn, or there's something that I need to go back and look at my fermentation that resulted in me having some beans that were under fermented. If they're under fermented, we're going to see purple. And here we've got a good example of a bean that has been somewhat fermented, right? We've got some brown around the outside, but some purple on the inside. This is probably going to be a good balance of bitter, which is coming from the purple, the heart healthy, as well as chocolate flavor here. Whereas this bean, there's no purple at all, right? This is a really, really well fermented bean. You're not going to have any bitter. I would expect no bitterness, very little astringency, and really strong chocolate flavor out of this one. Now, for most people, this particular piece of equipment is really, really expensive. It's thousands of dollars. I don't know why it is. What I would suggest for most people is to just use a garden shears, right? And so what you can do is take the garden shears, take a bean, half, and then we can, you know, assess the inside of the bean with that. If you do that 50 or 100 times, it'll take a little bit longer than this. The nice part about this is that it's very rapid, where you can do 50 or 100 beans in one cut, whereas this, it may take you 10 minutes to do it, but this costs, you know, $3 US, whereas the Magra book cutter costs $3,000 US. So a shears may be a better way to do that. What the shears will also allow you to do is, as you're cutting your beans, you can look for if there's any sign of infestation sometimes, or mold. Sometimes in your beans, if their beans were dried improperly, if they were dried too slow, that mold that we saw in the fermentation box will continue to grow on the inside of your bean, and you won't be able to see it until you cut your bean in half. So cutting your bean in half not only allows you to assess if you've got, you know, a good fermentation or a purple fermentation or a brown fermentation. It'll also help you assess if you've got moldy beans that you couldn't see, or if sometimes you also get insects that are inside there as well. And again, we can set specifications for all those things. Finding one bean in 100 that has a little bit of mold in it probably isn't a big deal. If you find 20 beans that have mold in it, there's something that went wrong, and we need to, you know, figure out what was going on there. Okay, so this is just a general overview of what you might expect to see during a fermentation while doing these cut tests. If you've got a well-fermented bean that you're trying to minimize any bitterness and really want to get the most chocolate character out of it, this would be the type of thing you would expect to see, right? You want to see lots of purple. You don't want to see lots of brown. You don't want to see any purple. If you're looking for a little bit of those heart-healthy compounds, you're going to get a little bit of bitterness that comes with that. But here's an example of something that is starting to turn brown, but it still retains some of its purple character. And you would expect this to have some bitterness and some chocolate flavor. This doesn't guarantee that it's going to be, you know, a high flavanol chocolate, because you can't control what your customer does with it. And your customer, depending how they process it in their plant, can either retain this material or they can destroy it. So you can only control what you can control. But this would be a good example of what a moderately fermented bean might look like. This is something that's fully purple, right? This would be considered a pretty poorly fermented bean. It did undergo some fermentation. We would expect this to be really, really bitter. This is probably not something you want to put in your mouth and taste. It's not going to be pleasant. It's going to be very heart healthy. You might live forever. It's just not going to be enjoyable to eat. This is going to have very, very low chocolate character to it. And then the far side of this would be a bean that would be unfermented. It's just going to look, we call it slaty. It may have a little bit of a gray character to it. There's not going to be any chocolateness, any chocolate character to it. And its fat levels are going to be very, very low. This is what would happen if you pick the beans off the tree and you put them on the dryer and you did nothing with it at all. Very, very low quality product here. Okay, and this is a generalization. So at this point, my hope is that you've got a better understanding of what's happening during fermentation and what you can do to influence fermentation. If you want more sour or less sour, if you want more bitter or less bitter, you now hopefully understand that there is no one right way to do a fermentation, but you can modify your fermentation in terms of quantity, duration of ferment, how many times you turn your beans. But generally speaking, when we think about regions of the world and the types of beans that they produce, over fermented beans, which would be thought of as beans that are very sour, these are typically coming from Papua New Guinea, Mexico, and Malaysia. So when we think about the maybe generational knowledge that's passed down from grandfather to father to children, what might be passed down is, just because this is the way they've always done it, is going to result in beans that are over fermented or quite sour. Generally speaking, West Africa and Brazil, their information that's passed down generationally is going to result in good chocolate flavor beans, right? So this is what most of the world is going to be desiring. And generally speaking, again, exceptions to these can be found everywhere, but in the Dominican Republic, Haiti, Sulawesi, and in some parts of Mexico, under fermented beans, so beans that are really, really bitter, really, really astringent, have lots of the purple color inside, but no chocolate flavor can be found in these areas. Now, what we didn't really talk about was, I think I acknowledged this at the beginning, is that everything we just talked about is roughly responsible for half of the flavor of your cocoa bean. The other half is the genetics of it. And typically when people talk about genetics of cocoa, they talk about Forastero, Trinitario, and Criollo. And that's wrong. It's way more complicated than that. There's dozens of different categories, but most people think about it in those terms. So we'll talk about that, because talking about, a couple dozen genetics is just difficult. So if you're working with something that you think is a Forastero bean, which is your bulk main product bean, you're typically going to want to ferment those for longer than you would a Criollo. So Forastero bean fermentation may run as long as 7 days to maximize the chocolate flavor. Whereas in a Criollo, which is typically regarded as maybe 5% of the trees that are out there, but tend to be your fine flavor beans, those are going to result in fermentations that are shorter. And why we're fermenting those shorter is because we're trying to preserve the amount of natural, interesting flavors that those genetics give us. A Trinitario then is the hybrid between those two. So if you have a Forastero tree that's cross-pollinated with a Criollo tree, what you get is a Trinitario, and that will have some of the yield and disease resistance benefits that the Forastero has, with some of the flavor that the Criollo has, and its fermentation period is typically in between there as well. So if Criollo is on the low end of fermentation time, like maybe 3 days, whereas the Forastero is in the high end, maybe up to 7 days, your Trinitario might be somewhere in the middle to try to optimize flavor. If you go past that, in addition to getting the molding that we talked about, you'll get some other off flavors that are typically called smoky or hammy, or if gone too long, they can become rancid, and these are all flavors that your customer is just not going to want. So I'm kind of wrapping up with the content that I wanted to give you guys today. And I think the 6 main points that I wanted to just come back and refresh on is that when starting your fermentation, it is critical that you start with good quality raw materials. They're ripe, they're non-diseased, and they have a Brix that is 13 or higher. Hopefully you understand now that you can create a pretty wide range of flavors by adjusting your fermentation, your times, your turns, your drainage, and there is no one way to do it, but that there are many different ways to create custom flavors based on how you treat your fermentation. Turning your beans frequently creates more sour flavors, and so you can create a range of sourness depending on how long or how often you turn, and that going past a fermentation of 6 to 7 days is going to increase the likelihood that you've got mold or toxins or bad flavors. The longer you ferment, the fewer of those flavonoids, the fewer of those purple materials are going to be present. I can't stress enough that doing things the same way is going to be key to getting consistency. The same starting quantity, turning them at the exact same time every single time, and that trying to ferment less than 300 kilograms may give you some inconsistent results because of that sensitivity to temperature drops and fluctuations overnight that we talked about. We talked about simple tools that we can use to measure your fermentation. I would say that a refractometer and a thermometer or a data logger are really, really helpful, useful tools. You can get a refractometer for as low as $20, and there's essentially really nothing to break. They're very hardy pieces of equipment. And a thermometer, of course, is very inexpensive as well. And again, I just want to call out that we haven't discussed drying it. That might be a good second topic, but drying is just as critical as fermenting. If you do everything right in fermentation and you screw up your drying, you've still screwed up your bean. And so we want to make sure that all the attention that you spent in fermenting, you spend the same amount of attention to detail in drying so that you don't inadvertently end up destroying the beautiful beans that you just made.